Okay, sorry, I just need to clear my throat there. We are going to cover a little bit with sheet metal. There is not a ton of things with this, but the things that are there definitely have a lot of capabilities. So first thing I want to get into is an older limitation which is now completely addressed, and that had to do with any lofted sheet metal component. We've had the capabilities to make these freeform shapes based on 2 sketches for quite some time. Now this is a classic example of rectangular to circular, a duct narrowing or a transition. We've never had the ability, however, to use sketches that were non-parallel, which this example obviously is showing us. If I go back to the raw version of this, you can see I have 2 sketches on planes that are obviously not parallel to each other. And when you select on your sheet metal tools to do a lofted bend, we're using some prep methods here where we leave a gap because, of course, you need the sheet metal part to be able to fold and unfold. But all we're doing is selecting these non-planar or parallel sketches, and as I select each of those, it's going to go ahead and give us the nice preview that we're looking for. Same thing I showed you on the weldments. Anywhere that you have these magenta dots allows you to change from the overall defining characteristics of how many facets or the chord tolerance or length, and actually individually select those and modify them one at a time. So if I wanted to have many more facets in this corner than in the others, I could change that one up independent of the rest. It then turns blue to indicate it's no longer driven by the document's defaults. As I say OK to this, you'll see the nice preview. Turns into a beautiful solid part. And then the flat pattern of that gives us what we need, which is the number of hits in the corner in order to go ahead and make this on a press brake or on a CNC brake. But non-planar profiles, or non-parallel, excuse me. Very nice. So let's switch back over to our completed component. A couple of things to note on this one. First of all, when you flatten a part like this, last year, 2014, we added a gusset feature to the SOLIDWORKS sheet metal components. When you flatten this, because a gusset by nature interferes with the bend, and on purpose in real life because that's going to give it strength, but as we flatten it, we need to remove it. So it's automatically put in the faces to exclude category of your flat pattern feature. However, when the flat pattern shows, we don't even know where it was. So under Tools and Options, there is a document property, so it lives with the file with the title block, or excuse me, with the document template if it's a sheet metal template for you. But it's down here to sheet metal, and it simply says show sheet metal gusset profiles when flattened, and then show their centers when flattened. And as soon as I do this, what you're going to see is a sketch representing those gusset locations appear on my 3D flattened part. Now, of course, when I uncheck flatten, it's going to remove that sketch and then show the 3D feature it is. But when it's in the flat pattern, that's got to be a keep out area. You can't interfere with where that gusset's going to go so that we don't accidentally punch a hole through it or put anything else directly adjacent to it. Every sheet metal feature has also had a preview, except for the sketched bend. So the sketched bend now has that. Let me just run through it and show it to you. As you sketch a bend, what you're essentially doing is taking either a pre-drawn sketch or drawing a new sketch, as I am in my case, and we're determining a bend that takes place around that edge. So as we go ahead and say OK to this line tool, it's going to complete the sketched bend by asking us for the fixed face, which will say this side's going to stay fixed. As that happens, you'll see the preview pop up, which it did not before. We'll go ahead and modify where the radius goes, the direction, and even the angle. Just make that 65. All right, and that should be parallel to the rest of those faces based on the angle of attack of that other face. But a preview is going to let you know this before we say OK, which was a little frustrating before compared to the rest of the interface. Last thing I want to show you on this is the creation of a mirrored part from a sheet metal part. Now, sheet metal parts I consider somewhat unique to other geometry because they're really more of a living, breathing thing. They start as flat material, and then they are bent up in an order and a process to create these 3D bodies, which kind of is more than just a milled part that you have a stock body sitting in your hand. So what happens with these when we try to use them in other places, and more particularly a mirrored, symmetric type of an assembly, is that we lose some of the behavior of that sheet metal resulting part. So SOLIDWORKS 2015 has addressed this. What we do is we simply go ahead and take the plane that we want to use to mirror this component. We're just going to go ahead and use the right plane. And then we're just going to simply go on to Insert and Mirror Part. Now the choices we get over here are things like sheet metal information, which if I go ahead and actually select each of these, that's going to transfer the sheet metal information of the part over to the new mirrored part. Now these sheet metal details include a lot of things. It's actually the flat geometry, what faces we've deemed as fixed, the grain direction, so the way that this is going to sit on blank material, the faces to exclude, which will be the things from the gussets, as well as things like the bend lines and their parameters, any sketch transforms like the gussets and the flat pattern, and then the forming tool information. So basically the resulting mirrored part, though in reality it looks just like the original, simply the opposite, it actually has all of the functional behavior of an original sheet metal part. So over here is my mirrored result. If we look at the sheet metal features, we see that we have a part, and then underneath that it's actually going to list out all of the individual bends. So we have each of those and the ability to go ahead and take a look at those. But what we also get down here is the ability to see all the flat pattern features. And each of these bends also is going to have some associative information. As a result, if I click flatten on this part, we're going to see a beautiful flat pattern that's exactly the opposite of the one that I showed you prior to this. And again, it has all the individual uniqueness so that we can go ahead and do things like individually suppress and unsuppress bends. So anytime we're looking at this part here, there's a derived bend. We don't want derived bends for this particular one. We actually just want regular old bends. But that's going to give us some capabilities to take any one of these other bends here and just simply go ahead and suppress it. This one's got some interference on those. So essentially, the capabilities are there, and it's going to give you probably the most important part of this. Let's take that one back just so this doesn't change. But let me make a drawing from this, this resulting mirrored part. So the drawing from the resulting mirrored part auto-populates, but only if the sheet metal characteristics are there. So if I take a C-size piece of paper and we simply go ahead and make a drawing of this mirrored sheet metal part, so our part 2, once my view palette pops out, I'll grab my flat pattern, but you'll be able to see right away that as the mirrored part shows, it has all of that intelligence of bend angle, direction, radius, and the unique individual criteria for each of those bends to be created. So much more usable when it comes to saving yourself a lot of time by creating a mirrored part, but not losing the capabilities or the behavior of what a sheet metal part represents.